Here's a brief video demonstrating how we analyze a gasoline sample using our VUV Analysis package. This is an offline software package. It sits in the same place in the workflow that a typical DHA analysis package might. VUV Analyze itself is a pretty general analysis routine with quite a few settings that can be optimized for a given application. But of course, the purpose of developing a method for gasoline is that these parameters are already optimized for that application. And so we're just going to load them via settings file in one fell swoop here, and then replace the chromatogram file with the one most recently obtained by the CDS system, and then click Analyze. The black bar here indicates the progress as it does the procedure I described above throughout the chromatogram. Down here you can see the green spectra is the total absorbance at each of the time slices, and the blue is the area under the fit. So these are very good fits that you're seeing there. And then at the end, of course, it reports the mass percent values of the various parameters reported by 8071. There's a carbon distribution available and an optional conversion to volume percent. And you've got a report that you can print out or something. This is the same information as on the prior screen there. And at this point, we're basically done. But I'm going to go over and take a look at some of these fits, and in particular, see how the software handled the benzene methylcyclopentene deconvolution that we were looking at earlier. And there's the benzene. Now, methylcyclopentene is not one of the compounds speciated by 8071, so it's here in the olefins bucket. And there you can see the olefin and benzene coelution and the deconvolution that resulted. If I click through here, you can see the spectral shape changing just like we saw before. And then there's the result where the software found benzene and an olefin, which of course is the methylcyclopentene. Just one other thing to point out, that because it's a spectroscopic fit, there's a fit metric, like a goodness of fit. And in particular, we report the chi-squared and the coefficient of determination, r-squared. And r-squared in particular, the closer it is to 1, the better the fit. You can set a threshold that will cause a software to reject fits that are below the threshold, and it'll report the total rejected compared to the total response in the form of a percent. And if an unordinary amount is rejected, like say more than 1 or 2% in an analysis, that's a potential flag to the analysis or to check out the measurement itself. So this type of, so it gives you an automated verification metric, which would not be possible with an ordinary FID response or other non-spectroscopic response.